Hello everyone, welcome to this KANPUR-NPTEL online course on space environment and its effects on orbital spacecrafts. So, in this module we discussed about the plasma environment. We started with the basic physics of the plasma, where we discussed how a charged particle or the motion of the charged particles is influenced by the electric and magnetic field. Then we considered the plasma as a whole, its collective behavior. Then we discussed the different type of the velocity distribution or the energy distribution function. Then how to compute the plasma fluxes. Then we considered this spacecraft as a probe, that is the Langmuir probe, and using the probe theory we discussed the current collection from different plasma species. And then we also discussed different types of spacecraft charging and what is the effects of spacecraft charging on the performance of the spacecraft's subsystems and the overall the performance of the spacecraft. We also discussed the mitigation, that is design guidelines and the mitigation topics. So, this we will continue, we will not continue here, but before I go to the next module, that is the radiation environment, I would like to discuss those topics which are where the mathematical formulae which will be which will be helpful for you to prepare for your exam. So, we will solve a few numerical problems using whatever the theory we discussed during the last 10 to some 14 lectures. So, we will take a few of them and we will give some examples today. So, that will be the aim is so that to help you in your exam preparation. Okay. So, this already I said. The first topic, if you remember, we started that is the motion of a charged particle in a uniform magnetic field. So, as you know, whenever the charge is moving in an arbitrary direction, and if it enters in a uniform magnetic field, then this particle starts gyrating. So, the question is, we are considering a positive charge of 10 to the power minus 18 coulomb, its mass is 10 to the power minus 28 kg and it is moving in an arbitrary direction, is intercepted by a magnetic field of intensity. So, this is the thing, and the initial velocity vector is given by this. Then you are asked that is what is the force and what is the trajectory and what is the that the parameters of the trajectory, like the gyro radius, then cyclotron frequency, pitch angle and pitch. So, we will solve it. So, given q is equal to 10 to the power minus 18 coulomb, then the mass is given 10 to the power minus 28 kg, and then the magnetic field intensity B is given by minus 10 k. So, means it is a z directed magnetic field, and then the velocity vector is given by it is 5 I plus 3 j plus k. So, this is Tesla. This is the Tesla, which is the unit of the magnetic flux density, Weber per meter square, and this is the velocity vector. So, this is meter per second. Okay. So now you can calculate the Lorentz force. So, Lorentz force is Q B, then cross product of the magnetic field vector. Okay. So when we have been asked, that is to prove that Lorentz force is perpendicular to the velocity vector. So, in order to do that, what I need to do, that I am to find the dot product of the velocity vector as well as the force Lorentz force vector, and show that is equal to 0. So, what is our Lorentz force? So, Lorentz force, if I want to find out, then I am to write it. So it is Q into P cross B. So, these two vectors. So, I can write it. So, Q is equal to 10 to the power minus 18 coulomb, and then in order to write this cross product, I should write it in this determinant form. So, these are the unit vectors along x, y and z direction. Then I will write it 5, 3, 1, these are the velocity components, and then the magnetic field component, that is this is only z directed. So, I am having this. So, the unit will be equal to Newton. If I evaluate this determinant, then I can write this is equal to 10 to the minus 18, then minus 30 I plus 50 j plus it is z component is 0. So, I can write it like that. So, now I can show that B dot f. So, B dot f will be equal to 10 to the power minus 18, then 5 I plus 3 j plus k unit vector, then the dot product of minus 30 I plus 50 j. So, which is equal to 10 to the power minus 18, 150 minus 150, which is equal to 0. So, this is proved. Okay. So, now since the velocity is having it is both the x, y and z component, that is it is having a perpendicular as well as the parallel component. So, the particle trajectory it will have a helical trajectory. So, particle will have a helical trajectory. So, this helical trajectory will have this, it is the radius, that is called the Larmor radius, as well as it will have its pitch angle and the pitch. So, let us find those parameters. So, the Larmor radius R L is given by, the formula is m into the perpendicular component of velocity divided by the charge and the magnetic field component. So, m b perpendicular component of velocity divided by the charge and the magnetic field, and if you compute this, but before that we need to have our perpendicular component of velocity. So, perpendicular component of velocity will be the x component square plus y component square and square root. So, this you will have 25 plus 9. So, this is square root of 34. Okay, and your B parallel is equal to, B parallel component is 1, that is I am writing the magnitude, or if I want to write in terms of the vector, then I should write it in terms of k. So, if I substitute this value of m and this V t and Q and V, then I can show this is equal to our mass is 10 to the power minus 28 kg, then this perpendicular velocity is square root of 34 divided by Q is 10 to the power minus 18 and B is 10 Tesla. So, it is. So, you get if you calculate this, so you will get an value 5.831 into 10 to the power minus 11 meter. Okay. So, next is the cyclotron frequency. Cyclotron frequency omega c, that is the cyclotron frequency. Radian per second. So, that is equal to Q B by m. So, again if you substitute the values of Q and B, so you will have 10 to the power minus 18 into 10 divided by m is equal to 10 to the power minus 28. So, you get 10 to the power 11 radian per second, and this you can convert it to you divide it by twice pi. So, you will get f c is equal to omega c divided by twice pi. So, if you do that, you will have 1.59 into 10 to the power 10 hertz. Now, you can convert it into gigahertz and all those things. Now, next is the pitch angle. Pitch angle is given by, that is already we have seen, that is given by tan inverse the perpendicular component of velocity divided by the parallel component of velocity. Okay. So, this you will get tan inverse 34, and so if you can find out what is its value. So, that value will be equal to something like 0.17 radian. So, you can now convert it into degrees. So, if you convert into degrees, it will be 9.7 degrees. Okay. So, now next you can calculate the pitch. So, what is pitch? Pitch is equal to parallel component of velocity multiplied by the period of gyration, that is T c. So, I can write this is P parallel divided by F c. So, already we have computed F c and B parallel is how much? It is 1. So, it is 1 by 1.59 into 10 to the power 10. So, this you can show this is equal to 6.3 into 10 to the power minus 11 meter. Now, the question number, the next question is, it is in a geosynchronous earth orbit. The typical electron number density in the plasma environment is given by this figure, and then the electron energy is this. Then you have to calculate the what is the plasma frequency, and you have to calculate what is the Debye length. So, for that you need to know what is the formula for the plasma frequency and the Debye length. Here, so we will solve it. Solution. So, given N e, that is the density of the plasma, these are what electron density. So, this is 10 to the power 9 per meter cube and 10 to the power 9, and then this is it is electron. So, the energy is given. So, it is given the energy is equal to 10 kilo electron volt. So, means it is 10 to the power 4 electron volt. So, 1 electron volt is equal to, you can convert it into joule, you can convert it into joule by multiplying it with so, you can convert it into joule. So, 1 electron is 1.6 into 10 to the power minus 19. Okay. So, this will be in joule, and then you can from here K T E is equal to this. So, you can find the K. So, where K is the Boltzmann's constant. So, this is equal to this figure 10 to the power 4 into 1.6 into 10 to the power minus 19 joule. So, the T will be equal to, you can use this 10 to the power 4 into 1.6 into 10 to the power minus 19 divided by 1.38 into 10 to the minus 23. So, this is joule per Kelvin and this is joule. So, finally, you get this unit is Kelvin, and this comes to be 1.16 into 10 to the power 8 Kelvin. So, then this you know, this is the charge of electron is, or I will write it, charge of electron is 1.6 into 10 to the power minus 19 coulomb, and the mass is 9.1 into 10 to the power minus 31 kg, and epsilon 0, we will need all these things in the formula. So, it is 8.854 into 10 to the power minus 12 farad per meter. Okay. So, now we can calculate the both the quantities. So, the first we will calculate the plasma frequency. So, what is the formula for this plasma frequency? The formula is the charge density Ne multiplied by its charge square divided by the epsilon 0, that is the permittivity in free space multiplied by the mass of the electron. So, if you substitute all this value here, so you will get this is, so it is 10 to the power 9, then we will multiply it 1.6 into 10 to the power minus 19 whole square, then epsilon 0 8.854 into 10 to the power minus 12, and then the mass is 9.11 into 10 to the power minus 31. So, this will be in radian per second. So, this value it gives, if you calculate it, it will give, this is again you can approximate it to the value 1788854 radian per second, and this you can convert it into in the hertz. So, this is f of this electron, this is the plasma frequency in hertz. So, this you will divide it by twice pi. If you do that, then you will get the figure something like it will be 0.284 megahertz. Okay. And next we will calculate the device length. The device length formula is lambda d is equal to square root of epsilon 0 okay, v, then T e, then n e square. So, if you substitute all this values as we substituted here, you will get this value is equal to 23.52 meter. So, here what is needed to remember the formula for these two quantities, then you will be able to calculate it. Only you have to take care of calculating the temperature. It may be given in terms of the energy. So, if it is given in terms of energy, the plasma species energy is kilo or electron volt, you have to convert it into joule when you put it in this formula. So, only this much you have to, otherwise you have to take this figure kb into T directly, that also will do. Okay. Now, let us do this problem that is again related to this device shielding only. So, here the problem is a charge is a test charge which is a point charge is introduced in a plasma environment or in a plasma where the density is given by this and the energy is given by this. It is the same as our previous problem. And then you are asked to find the charge when the charge in free space or when the charge in the plasma. What is the difference between the potential? So, this for finding this already you know, for this already you have calculated. If then you have to follow the same procedure of the earlier problem, then it is 23.5 meter, this already you have calculated. Then this phi in free space. So, this is given by the simple formula, this is given by q by 4 pi epsilon 0 into r e to the power minus r by lambda t. Oh no, this term is not there, it is free space we are doing. So, this if you put here the r is equal to 100 meter, then you will be able to calculate this figure as minus 540. This will come actually 0.54 volt. Okay. Now, if you if you consider now this charge is there in the plasma, this charge have been introduced in the in a plasma environment where the density is given by this, then what you need to do, you have to use that formula for the potential. Now, the potential formula in the plasma, so plasma that shielding will be done. So, this formula will change. So, what it will come? So, it will be minus 0.54 and then e to the power minus 100 by 23.5. So, if you do that, then you will have this value, it will have something like 0.007 volt. So, it is almost coming to 0. Okay. So, the next problem. So, here you are asked in this this problem to you are given a magnetic field and the both the magnetic field and the electric field. And now, if a charge is moving in presence of both the electric field and magnetic field, then it will have a helical path, it will gyrate in a helical path along the magnetic field, as well as it will have a drift which is perpendicular to both the magnetic field and the electric field. So, that what is that formula? We know that formula is that is the drift velocity, we derived that quantity earlier. So, drift velocity is given by drift velocity V d is given by divided by base square. Okay. So, you have been given E and B. So, you have to compute what is E. So, you can compute it I j k then everything is 1, the E vector everything is 1 and the J vector is having only the Z component. So, it is 8. So, you will have this is 8 I minus 8 J. Okay. Now, what is the our that B magnitude of B is 8. So, I can calculate now the velocity V d is equal to B drift is equal to 8 I unit vector minus 8 J unit vector divided by 64 and its unit is meter per second. So, it is 1 by 8 meter per second. And since both quantities are that is B d is it is a cross product of the electric and magnetic field. So, it is perpendicular to both E and B. Okay. Now, this question. So, here so what is there electron is moving in magnetic field of this is 2 milli Gauss and the speed is given by this, and then you are asked to consider the magnetic field is in the direction which is parallel to z axis and the particle is moving in an arbitrary direction having the components in the x and y plane as well as in the z direction. Okay. So, this is the magnitude actually given to you. So, it is said that if the pitch is 25 meter, what is the velocity along the magnetic field and magnetic moment. So, we have to find the both the components, that is the parallel and the perpendicular component. So, here we will write. So, your B is 2 milli G. So, 1 Gauss you have to convert it to Tesla. So, that you can directly put into those formulas. So, into 2 into 10 to the power milli means 10 to the power minus 3 and then 1 Gauss is equal to 10 to the power minus 4 Tesla. I will write Tesla. Then it is 2 into 10 to the power minus 7 Tesla. 2 into the minus 10 Tesla, and then your B e, that is the magnitude is given, as 2.44 into 10 to the power minus 7 kilometer per hour. You have to convert it into meter per second. Then it is 6.78 into 10 to the power minus 10 to the power 6 meter per second. Okay. And here the pitch is given as 25 meter. So, now you need to calculate first the gyro frequency. So, if putting q b by m, you can calculate it, and then this, because I will need the T c. So, T c I can find it that is 1 by f c. So, it will be basically twice pi m divided by q b, and if you put all the values you will get 1.8 into 10 to the power minus 5 second. Okay. Now, P is equal to V parallel T c. So, from here now you have T c, you have P, so you can find V parallel. So, V parallel will be equal to 1.4 into 10 to the power 6 meter per second. So, once you have the parallel component of velocity, you have the total velocity, you can find the perpendicular component of velocity. So, the perpendicular component of velocity will be equal to it is the total velocity, that is B e square minus B parallel square. B parallel square. So, if you put all those values of, that is the parallel one, and this is also already known. So, this will give you 6.6 into 10 to the power 6 meter per second. So, once you have this perpendicular component, you can now find the magnetic moment. So, magnetic moment, that what we discussed, we derived also this magnetic moment formula is, that is given by the current into the gyro radius. So, that gives you actually the formula, it comes m into the perpendicular component of velocity divided by twice b, and if you put all those values, you can show that it is equal to 2 into 10 to the minus 10 joule per Tesla. So, these are a few problems I did it, you can practice for your exam purpose, and next session we will start the radiation environment. Thank you very much.